Right, hi all. This is my video number 17. So in this video, I'll talk on the two-dimensional array. Yeah, we still deal with the array now. Two-dimensional array. Two-dimensional array. In the previous video, in the previous lecture, I explained what is array, how to use that for one-dimensional case. Yeah. So if you just we declare integer num with some numbers there, you can put whatever there, or you can leave it blank like that. So this means one-dimensional array. Yeah. For two-dimensional arrays, if you look at the look at your notes, definition is there. So this is the example of two-dimensional array, which means integer test score 202. So which means in this case we have 200 rows and 2 columns. Yeah, so 200 rows and 2 columns. So we have row number 1, 0, 1, 2, and so on up to 199, and 2 columns 0, 1. Okay, so the element, this is element 0, 0, 0, 1, 1, 0, 1, 1, 2, 0, 2, 1, and so on and so forth. So it is important, for example, if you want to calculate the matrices, to do a summation, to do subtraction, to do a multiplication of matrices, and many other applications that you can use to store test result for each of the students. You can do that as well. Now the this is the example. Yeah, the collection of test scores for a class of 200 students who took 2 exams, and this is test score 40, test score 41. So which means that student number 4 with the first test, student number 4 with the sorry, this is 4, this is student number 5 should be student number 5 with second exam. Yeah, because the index begin with 0. Yeah, 0, 1, 2, 3, 4. So 4 means student number 5. Okay, that's the example. The general form of declaration, the two-dimensional array. So we have type. Yeah, the array names, you can give whatever array name. This is just a type of array. Type, you can integer, either integer, floats, or a character or string, right? And the size of row and the size of column. That's the general syntax for to declare the array for two-dimensional. Okay, another example, if you have that integer m, 10, 20. So here m is declared as a matrix having 10 rows, yeah, and 20 columns, 0 to 19. Then we can also initialize the two-dimensional array. So how to do this is given is here. The example, if you have this is the variable names table of type array 2, 3. So which means we have 2 rows and 3 columns with this initial value 0, 0, 0, 1, 1, 1. So what does this mean? So it means that table 0, let me write it here. So we have table 2, 3 with the initial value 0, 0, 0 1 1 1. Okay, so each of those elements, I just write t as a table. All right, t 0 0, that take the value 0. Right, t 0 1, take the value 0, the second element, and t 0 2, that's 0. And then table 1 0, that's next, which is 1, and table 1 1 is also 1, 1 2 is also 1. So this is 0 0 0 for the first column, first row, the 1 1 1 for the second column. Or you can also write in a much easier way to read, so it's not confuse you, it's not confuse the reader. So this is for the first column, first row, this is for the second row. That and that is acceptable, but the second one is much easier, so that you can split the each row that you want to put in. Okay, now this is another example given full program. So what does this program do? So we have integer ti, num, and 4 and everything. Here I would suggest you put the open braces and close braces, yeah, for after that 4. All right, so let's try to read this program. Okay, let's try. What's the output of this program? It's not given in your notes, so let's try. So here in this case we have integer t and I, and we have array called name of type integer. So if you want to work out this thing, so you do that. So we have we have t, we have I, and we have array names num. Okay, so if you look at your program here in your notes, t begin from 0 to 2, I have 0 from 0 to 3. So when t equal to 0, it's come into the inner loop, I equal to 0, then it's increase I one by one until I3. When I is equal to 4, which is not true, then go out from that loop, then it goes to the outer loop. To the outer loop. So let's do that. So here t from 0 until 2, right? So at the beginning, the value of t is 0, the value of what I is 0. So if you calculate that the mathematical formula, so 0 0, t is 0, 0 times 4 is 0 plus 0 plus 1, that gives you 1. So sum here is 1. All right, then it's increase I, t is still 0, increase the inner loop, I is 1, then goes again into that formula, that's 0, 0 plus 1 plus 1, that gives you 2, and then increase I, 2, then again do the computation. This is 0, 2 plus 1 is 3, so that you have 3. Now the value, now not one more, so one more, so I is 3, then you got 4 there. Now when it's increase I equal to 4, 4 less than 4, which is not true, then it's out of that inner loop, it goes back to the outer loop. So outer loop, increase t 1, yeah, increase t by 1. So now t, instead of 0, we increase 1, we got 1. So t is 1. t is 1. Alright, then what happened when t equal to 1, it goes again to the inner loop, then increase, then I equal to 1, then check everything and do the mathematical work there. Okay, so I equal to 1. So if you do that, so we have t 1 times 4 is 4 plus 1, 5 plus 1, so 6. 4, 5, yeah, 6. 6, right? Am I correct? So we have 1 plus I is 0, 4, 5. So here this is 5. Okay, and then increase I 1. So we have 4 times 1 plus 4 plus 1 plus 1. So that gives you 6. Then increase I 2. Then 4 plus 2 plus 1, 7. Then increase I again 3. So we have 4 plus 3, 7 plus 1, 8. Alright. Then I equal to 4. I equal to 4. Then that condition is not satisfied. It goes out from the inner loop. Now again go to the outer loop. Now increase t. Another 1. So we have t now is equal to 2. Then go again into the inner loop. Then start with I equal to 0. Then do that formulation again. 2 times 4, which is 8, plus 0 plus 1, that give you 9. That give you 9. Then increase I by 1. So 8 plus 1 plus another 1, you got 10. Then increase I 2. 8 plus 2 plus 1, you got 11. Then increase I another 1. So 8 plus 3 plus 1, you got 12. Then I equal to 3. Increase I equal to 3. So when I equal to 3, it's not satisfied that condition. It's not satisfied that condition. So out of that outer loops, then it goes to the next process. Next process is to print the output. So if you print that output, you will get something like that. Okay. So in terms of arrangement and prints, that's depend on how you write. Right. This is the way of working for that example. Okay. So I suggest to be more understand, try to write this program or just copy this program into your C and then compile by yourself and check, and you can play around with that. Play around, I mean you can arrange, rearrange, whatever in what arrangement you want to put in. Okay. Now if you go to another example, in this example, what we do here, this is the matrix represented by two-dimensional array. So we have matrix A 3 by 3, matrix B 3 by 3, and matrix C 3 by 3. Matrix C, we don't have the initial value here. Why? Because we want to do some manipulation on AB, and then we store the value into C. So C has no initial value, but A and B, of course, we have the initial value. Okay, so first row of matrix A is 2, 4, 6. Second row is that, and third row is that. And for matrix B, first row, second row, and third row. Now the first part here, the first few lines here, print A, print B. So what the compiler do is just print each of those elements. Okay, print each of those elements. Of course, you can write in better way. Instead of write one by one like this, you can use 4 loops. Just make 2 loops for I, for J, and then you can print A and B, yeah, without doing like this. I mean, if you don't understand, you can write like for, yeah, I from 0, I less than 3 I plus plus. All right, and then make another one, put J equal to 0, J less than 3, J plus plus, and then you can do print A, write full, yeah, this part here I just write, means print A here means I print the matrix A. The syntax, please follow the what follow the syntax for print, yeah, print I. And then to print the matrix B, you can print here matrix B, but what happens if we print here, they might mix with matrix A. So to split them, we do it different. Another loop, yeah, I equal to 0, I less than 3, I plus plus, and another loop, J equal to 0, J less than 3, J plus plus, and then print matrix B. Okay, you can do this. This is I think this is, of course, this is a better way as compared to this one. So why the author did this, because just to want you to understand how to read, how to print each of those elements, yeah. So this is the element 2, 4, 6, 0, and so on and so forth. So it's print that element by element. Okay, now if you go to the next parts of this program, so what we do here is we do the matrix multiplication of the matrix. Okay, multiplication of the matrix. So now in general, what we do, if you multiply 2 matrices, let's say I have 2 matrices, A11, A12, A13, A21, A22, A23, A31, A32, A33, and I have B11, B12, B13, B21, B22, B23, B31, B32, B33. Okay, if you do the multiplication of that matrix, we obtain the matrix, say matrix C. So the first element of matrix C is by multiplying the first row of matrix I with the second row, first column of the matrix B. So if you do this and add up all those elements that you obtain, okay. So what we do for C11 or C00, so we have A11, sorry, this should be begin with not, because our array begin with 0, okay. So 0, 0, 0, 0, 0, 1, 0, 2, 0, 2, and so on. Change everything here. This should be 1, 0, 1, 1, 1, 2. This should be 2, 0, 2, 1, 2, 2. And as well as with that. Okay, you can do that part as well. So for C00, so we have what do we have? Theoretically, we have A00 times B00 plus A01 times B10 plus A02 times B20, correct? Yeah, that will give you C00. So where this not come from? If you look at all this, see this thing. So you can see that each of these first element, first row, that with the column that. So as well as that. Okay, as well as here. So that give you C naught. Okay, and yeah, that's correct. So that give you C naught naught. So whereas for that 0 0, that one 0, that one 0 is changing 1 1 2 2. So in general, how do we do this? So what we do, if you want to multiply for any row J, row I, and column J, so what we have is that A, matrix A, we need I, we need K, B, K, Kj. Okay, so this K, where the changing index is, that 0 0, 1 1, 2 2, and then we need summation as well. You need to sum up all those things. So it means that we have Cij plus equal to all these things. So which means here that Cij is equal to Cij plus Aik Bkj. So since we have plus here, we need the initial value for Cij, which is for the plus, with the initial value for Cij is 0. If you don't put that, if you don't give the initial value, it might give you the wrong answer. You can try that. Okay, now let's go to your programming. Remember this, that the formula for multiplication of the matrices, of two matrices. So if you look at your programming here, multiply B times A, which means B first then A. So we have two for loops, two for loops, which is I and J, that for C not C, which is Cij, and then we give the initial value. If you look at this, that I explained earlier, that we need, because we do summation here, repeated summation here, we need the initial value for C, so that we give, for summation we give C is 0, if multiplication we give C is 1. So in this case, summation we give C is 0. Now we have C is 0, Cij, because, and then we need another loop for K. This loop for K, this loop for K is for that. Okay, because summation here, each of the summation, we change K, from 0, 1, and 2. We change K. So means we need a loop for K, and then we do the multiplication. So this process here will evaluate, or will calculate the each of element of C, each element of C. So this part here, where the rows multiply by column. Okay, so I hope you understand that. Now this is the print process. Again, the print process, you can do like as I suggested earlier. Instead of using prints one by one like this, you can just do like that, 4 4 and 4 4 Ij, then you can print AB. If you want AB, you can print C, Ij, and so on and so forth. Okay, I think that's all. Okay, so we have now we have two cases here. this is A times B, this is A times B, this is B times A. Nothing much change, thus just you change the position of A and B. This one is A times B, that one B times A. Okay, so remember that if you do the matrix multiplication, because we have 3 variable need to or 3 index need to be changed, so you need 3 for loops. Yeah, you need 3 for loops or 3 loops that you will use for to evaluate those things. Okay, that's the matrix. If you do this, I think we have the output for this program here. Yeah, this is an example for A and B that. So you can have A and B. That's the output for those multiplication, for those matrices A and B. Of course, in this case, yeah, in this program here, the matrices A and B, the element of those matrices are given beforehand, means is given in as an initial value. You can, if you want, insert this initial value through your screen. If you want to do that, so in that case, you need to have for loops somewhere here. Yes, for loops, and then you need scanf. So those two for loops, scanf, so that you can insert each element for A and B. By doing that, you can choose, each time you will run the program, you can choose different set of matrices, yeah, without changing here. Right, so with those example, I explained on the bit application of that example, yeah, how to use two-dimensional arrays. Here still that two-dimensional arrays, but we need another one because of the third element of the matrices changes when we do the multiplication. I think I have to stop here for this video, because next we need to go to strings. That's also need a little bit quite lengthy explanation. So for this we stop here. So thank you.